In this project, I'm going to show you a wireless energy transmitter based on a joule thief circuit and a air core transformer. Here's the current draw with a 2N3055, 1.5 volt battery and 1K resistor connected to the base. The transmitter coil is 3.5 inches in diameter, 10 plus 10 turns of 18 gauge wire. The receiver coil is 28 gauge wire, 30 turns connected directly to a white LED. And it works pretty well. It oscillates around 666 kilohertz. Here's it running with a whole bunch of them all thrown in there. Some of those have multiple LEDs connected together in parallel. And this is using the same setup. It's not changed the current draw. Now we're going to switch from the 2N3055 transistor to the MJE13007 transistor, and as you can see there, it's pretty good. It needs a 100 ohm resistor at its base for the MJE to work, but the current draw is higher. It's around 135 milliamps. You can see they're all lighting up. Now I'm putting the 1K back at the base of the MJE transistor, and we'll see how well it works with the 1K resistor. And got the alligator clip there on the heat sink, which is connected to the collector. And you can see there it's not very bright at 1.5 volts using the 1K resistor, and it's very minimal current draw. It's around 15 milliamps. So less efficient in terms of brightness. And some of those don't even light up. However, when you change the battery to a 3.7 volt lithium-ion battery, everything lights up brightly with this particular setup. And the current draw, as you can see here, is around 70 milliamps. Now let's test it underwater. I've thrown one of those coils, which is this one, which is 40 turns of 28 gauge wire, into water, and it lights brightly underwater, which has some pretty good uses for charging devices and things under the water. Here's another light added in. You can fill this whole cup up with lights and it will still work. I've already tried that. Okay, now we're lighting the same coil, or one of them, with the red LEDs right through a piece of wood. This is actually my table, which is about 1.5 to 2 inches thick wood. It'll also work through concrete and makes a nice setup for transferring energy through an enclosure, as you can see here. The frequency measures out at 666 kilohertz, and they're sinusoidal waves, as you can see there. Because of its simplicity with only 2 components, this is a great starter project for those interested in electronics. Thanks for watching, and please subscribe.